In this video, we are going to do problem number 27.04, file system part 3. So this is going to be a continuation of file system part 2 in 27.01. What we're going to do in this video is that we're just going to do one problem involving mutual recursion, backtracking, and searching. And then we're going to go look at how backtracking works at a more mechanical level and debunk some misconceptions about backtracking and searching through a tree. All right, so I already have the file downloaded and open up in Racket. So let's just scroll down here and look for the problem statement. Again, this is a continuation, so all the templates are already done for us. All the scaffolding needed, all right, that'll help us out a lot. And the data examples are also done for us, all right? And here are some diagrams. I'm just gonna grab one actually, so I can stick it up here, because we're gonna need to look at it. So I recommend you do something like this, or have it on another monitor or another tab. All right, there we go. Hopefully that's big enough for you guys. Let's go down here, and here we have problem A. So problem A says, note that the data examples are done for you. So we just saw an example of that above, and also the templates, so the scaffolding as well. And it's carried on from 27.01. So if you haven't done 27.01, I recommend you pause the video and do that problem first. Design a function find-filesize that consumes a directory, right, a dir, and a string, which is going to be the file's name, and produces the file size of the file in the given dir. All right, so you should say in the given dir. Let me just write that down, in the given dir. All right, a few tests have been done for you. All right, so let's actually go through this. So we have find file size, the signature, consumes a dir and a string and produces number or false. Produces the file size in the given dir if the file is found. All right, if the file is found in the given dir, otherwise produce false. All right, and we have a bunch of tests here, so let's just go over them. So asdf.txt is not in this document tree, directory tree, so we produce false. We have part 3 here, and it is in the scripts folder. So we see scripts here. It just means that we're just considering scripts as the entire directory. All right, we have to do here, and it produces 10. So to do is right over here, it produces 10. This part 3.rtf is in the scripts folder, and it produces 17, right? So it's these numbers in the parentheses over here. And we have cover.pdf, which produces 2. So cover is way over here, and its file size is 2. And we have the stub over here, all right? So pause video and grab the templates above and try to solve this problem on your own. I'm going to go for spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing in it, so now let's go over it together. So let's grab the templates first. So all the scaffolding that they gave us that we can use to bounce off of. All right, so we're going to need all this and then the file template. All right, so I'm going to grab those first, like so, and then I'm going to grab the one that is the file template, which is this one, because it's being separated by this structure definition, and I had to do it in 2 steps because it's kind of in the way. Okie dokie. I'm going to paste that down here. All right, so the function that we're building consumes a directory. So let's use the template that consumes a directory. So it's going to be dir-temp, right? So we want to use this as a starting baseline, right? So the signature is already done for us. So let's just delete it. And also this to-do comment. All right, so let's just get started with this problem. So is this problem find file size? I'm going to rename it dir-temp. Everywhere we see dir-temp, we should rename it to the function that we're trying to build. Right, so dir-temp over here, and then dir-temp over here, right? Find file size requires 2 arguments, the directory and then the string, which is going to be the file name that we're looking for. So the find name itself. All right, so we're going to need to, everywhere we see find file size, right, we just renamed it. It's going to require 2 arguments, all right? And where is this, right? This helper function is going to call us back, and it requires a find file size because we just said it did. So where is it going to get it from? Well, you can assume that we need to get past it. So someone's going to have to pass it to us, right? Because I call a function that requires it. So everywhere we see list dirs temp, we have to pass in the find file name. All right, and I think that is it. Right, list dirs temp, my bad. So it's this one. All right. So list dirs temp, and that's list files temp. I think we're good. All right, so let's just keep going. Let's work on the simple case first. So let's actually ask the question here. dir-name of the directory. Do we care about the names of the directories like scripts, documents, life, work, and school? Not really. We don't really care about the names. We care about the names of the files and the number attached to them, which is their file size. So we don't care about the names of the directories, so we can just delete this one over here. All right. So let's actually do the simple case where we're looking for a file that is our files, right? So this test over here, scripts part3.rtf. So scripts, right? So by passing in only scripts and not the entire documents tree, right? What we're saying is we're only considering this part. So does a part3 exist? It is over here. If so, produce 17, right? So this is the simple case where a directory only has files. It doesn't have subdirectories, right? Like so. There's no subdirectories. There's only all files in the scripts folder. So that's going to be the simple case function over here, which is something that consumes a list of files and then produces either the number associated with that file or the false, right? Because that's what this function produces. So we're going to need the find name because, you know, we're looking for something and you have to be told what we're looking for and then produce what I produce. Right, I have to produce the number of false, so it's most likely the helper functions also have to do that. So this is going to be list files temp. Let's actually come up with a better name for this. The book recommends you do something like this, where you grab the same name and then just do like this, but then type in like list of file, right? Because this is going to be a helper function for this. But I'm going to come up with a different name and call it search-curr-files, right? Because it's the current files in the current directory, right? In the current given directory, right? So everywhere we see, what was it? List files temp, we rename it to search-curr-files, right? And we just deduce the signature for that, which we just have to pass in the find name. I just realized that. The find name. All right, so which is going to be this one over here. All right, list of files. Consumes the list of files. We just deduce the signature. You need a find name, and then the string, and then since it produces it's a helper function for you, then you need to do this. All right, so pause video and try to do search-curr-files on your own. All right, I need to rename the natural recursion as well, and also make sure that it also calls two arguments, right? Because 1, 2. So this is 1, and then the find name. All right, so that's the mutual recursion, right? So we see a mutual recursion for a list of file, right? And then the code mirrors that. All right, so pause the video and try to do search-curr-files on your own. I'm gonna go for spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it. So now let's go over it together. So let's write some tests for this. If you're unsure what this does, all right, always just write the test if you're stuck. All right, so I'm just do a few tests just to elaborate this. So list of files, right? So they're going to be like, so if I pass in, let's see, dir-subs, right, dir-files of scripts, right? What that's going to get us is all these files, right? They're going to be in the file structure, all right? And then we pass in a string, so we can say costume.png. So we're looking for this file, right? So that's going to be 100. All right, and you can do more examples if you like for other directories, but this is good enough. Let's do one for the empty case, right? What happens if the list of files is empty? And we're looking for costume.png. Let's come up with a different name, say SDF. Right, this is going to be false because it's not going to find it, right, in an empty list of files. All right, remember files are structures. They're going to be entire structures. They're not going to be just simple strings like this. They come with a number attached and the contents. All right, so anywho, hopefully this test clarifies what this function does. Let's just go over it. So given the empty list, we produce false. All right. Otherwise, we produce the number if the file name matches the file structure, right? Because either you find the file and produce the number, or you produce false. So that kind of indicates we need an if here, right? We need to do some decision making. So if the file name, so this is going to be the file of every file in the list, right? As it recurses. All right. We're going to say, hey, are you equal, because they're strings, are you equal to the one that we're trying to find? right? The file name, right? If so, we do something. All right, what do? Well, if you find the file name, we want to get the number attached with that file name, right? So 100 for costume.png. And we do that with the struct accessor file dash, it's gonna be size, all right, of file name, this first over here. All right. Otherwise, we do the recursive call. All right, so I kind of want to run this, but we're getting a lot of mismatches, errors here. Someone comment and try to fix some of these errors. So jump to error. It's a duplicate definition. I think we're fine, right? Just assume that this works and I'll fix it later if it doesn't. So let's actually move to the other helper function that we're supposed to do, which is the one that recurses subdirectories. So this one is the one that doesn't recurse subdirectories. It just says, hey, given my directory, check all the files in my directory. Don't look at subfolders and subfiles, subfolders, yeah, subdirectories. Right? Just look at the current ones. So let's do the one that traverses subdirectories, the list of directories right now. So given list-dirs temp and then consuming a directory and a file name, so that's going to be a string, what should this function produce? Well, usually you can use, the function that is calling this as a helper function. We can kind of use this as a temporary. So this isn't always going to be the case, but it's going to be the case most of the time. All right, so let's just leave those question marks there and then we can resolve it later. All right, so whatever you are that traverses subdirectories, you are going to have to produce this and also consume a string. All right. All right, so this function is going to traverse subdirectories, right? So it's going to do this. So let me grab my pen out. So if I have subdirectories, like say documents, right? I have subdirectories, scripts, and life. So I'm going to traverse you and then traverse you. And then this, right? This function is going to call us back and then traverse its subdirectories, right? So this function is going to call us back, right? So I'm trying to traverse my subdirectories, right? And then those subdirectories need to traverse their subdirectories. All right, so that's a mutual recursion. I'm gonna uncomment this out. Let's call this find-filesize-subdirs. Find-filesize-subdirs, right? Usually find-filesize dash subdirs, right? To indicate that this is a helper function. Okay, like so. And let's rename the recursion here because there is a lister, that's the recursion. So there we go. All right, and this recursion requires the find name. All right, so pause the video and try to do this on your own. You might need to write some tests to make sense of what this function does. I'm gonna go for spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing in it. So now let's go over it together. So let's actually write some tests for this just to clarify what this does. So check, expect, find-filesize-subdirs on a list of directories. So list, and then let's say scripts and life, because those are the subdirectories of documents, right? They're a list of directories. So scripts and life. All right, so in the scripts and life directories, right, scripts and life, let's write the file name that we're trying to look for. So let's say part1.rtf. All right, so we'll say part1.rtf. So there we go. That's going to be the file name, right? The string part1.rtf. Right, if it's in one of these two, then we reduce 99. All right, so that's one passing test. Let's do the failing one. Let's say we're given empty. Right, given empty, we produce false, right? Because false means they can't find it. All right, according to the signature like so. And if you read the statement over here. All right, let's do one more test actually. Let's do just life, right? We're just focusing on list life. I'm gonna move this up actually. And given list life, right? Life, remember life has two subdirectories, right? No files underneath. So given life, we're going to say look for to-do.txt, which is 19, right? So 19. All right, so hopefully this clarifies what this function does. Pause the video and try to do this on your own with these tests. Hopefully it should be all the mental scaffolding needed to solve the problem. I'm going to spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it, so now let's go over it together. So given the first test here, if the directory is empty, you should produce false. All right, so now comes the hardest part. So either you find it, which is these two tests, and you produce the number, or don't, and you produce false. All right, So that indicates we need an if here. All right. So if, there we go. So if you find it in these subdirectories. So for this test, for life, right? Life has two subdirectories, work and school. And to do is on the one that's way over to the left, right? The school one. But it's still going to have to look through work first and then look through school. So it's going to do this execution, right? Look here and then check these two files and then go back up to life, then go down to school, then to do. All right. So this function already deals with finding things in a directory, right? So check these directories under life, right? So given that, we can actually just copy and paste this signature down, because we're calling that function when we renamed it from the templates. And this will help us reason through what this function to do. Right, so if you found it, right, which is going to produce number or false, we can ask if we found it by saying number, right? So are you a number? If you're a number, then just give me that number back. So we can just do that. Otherwise, the false part is going to come through this recursion over here, right? So this isn't come through this recursion, right? And then this false isn't come from here, from the recursion, right? False for the signature. All right, so I think that is good enough. Let me just jump to the error I have, which is this template that we didn't really need to use. So I'm just going to delete it. All right, so now I'm going to assume this works because I don't want to bother with errors for the sake of time. And let's go back to this main function over here because we just finished the two helper functions. Now we have to compose it together to finish this main function. So let's just do that. So looking at these two helper functions, this helper function was the case where it was simple, that I just looked at my current directory of files and I don't have to traverse any subdirectories, right? So this is the case, like given this entire documents tree, let's say I'm looking for the file to do, right? Well, it's just right under me, right? I don't want to look for the one all the way here. I want to grab the one immediately right at me, all right? So this, again, is the simple case where we don't traverse every subdirectory. So if we find to do that is right under documents, right at the same level as documents, right under documents, then produce 10, right? So otherwise, right, keep looking, right? So let's say we're looking for cover, right? So it's not in my current one, right? It's not in the other ones, right? Scripts, let's go traverse scripts first and then go back up to documents and then traverse all the other subdirectories, right? So it's not in my current it's not in the file under me. It's not my files, the documents files. And it's one of my subfolders documents. So that is that function here. All right. So let's do if. We need an if here, right? If we find it immediately, right, then we produce. All right. So if we find it immediately, so let's just write the signature here, right? Then that means that it's going to be a number, and therefore just give me that number, right? So number. And that is going to be this again. And hopefully your spider senses are kind of tingling here, right? Because I'm going to delete this because I just copy and pasted it up there. Because, let me just delete this. There we go. Because we have some duplication here, right? So this is the same as this, right? It's the exact same code. And we can factor that out a little later. Otherwise, we call this, right? Otherwise, we look for our subdirectories. So let's just run this and hope that it works. And we get a mismatch here. Let's see, life 19. So given life, let's find in subdirs given life to do 19. Interesting. I kind of don't know why it's doing that. So let's just make sure that it's not the, so school to do is 10. So something messed up with this, right? This should be 19. So I'll probably fix this, right? The file size for this is wrong. It's not matching the diagram over here. So for some reason it was 10. So there we go. Interesting. So this is find file size. Oh, wait, no, that was the one for it right under documents. Okay, I see the problem. There we go. Let's just return to where we were. This differs from 19. Right, so under school we have, so this is school, we have to do 1, which should be 19, but the one for here is also. All right, so I messed this up. This should be to do school, and this one should be 19. All right, That explains it. So there we go. That's the to-do under school, and then this is the to-do under documents, right? The to-do under documents should be 10. The to-do under school should be 19. They both have the same file name, but different file sizes. All right, there we go. So all 9 tests do pass. So if you wrote your data examples wrong, then do be conscious of that. But it looks like all the tests actually do pass. All right. So now let's test, review, and refactor. So again, if you see duplication, you should factor this out into a local because this is going to run twice and it's going to result in exponential blowup. So yeah, I recommend you watch my video on local as to why that is so. So since this is the exact same as this, we can factor it out into a local variable. And we're going to call this search, we'll say incur, right, in the current directory. So everywhere we see this, we're going to paste this in, incur, and then we can just replace this whole thing with incur, right, this and this. Right, so this, and then this. Right, everywhere we see this. And that should fix the exponential blowup. And now let's just make sure that this is going to be inside the local, which is right under this parentheses, right after this square brace. So there we go. Just going to make sure that you are under that local. And let's fix this parentheses. All right, run the same test. It still passes. It's just a lot more faster, right? Because we don't have exponential blowup. All right, and let's do the same for check file size, right? Find file size subdirs, I mean. This and this are the exact same. Find file size first dirs find name, find file size first dirs last name. So factor that out into a local variable to make it faster, run faster. So let's call this check subs. And you are going to be there. And then we're going to replace you with check subs everywhere we see this. All right. So there. And then we're going to stick you inside the local, which is right under there. All right. And there we go. Fix this parentheses. All right. So if I run this code, same behavior, just much faster and much cleaner code. All right. All right. Anywho, I think this video has gone on long enough, so I'm going to save the explanation of backtracking for the next video. So submit your problem into Handin and check your score, and I will catch you in the next one.